Good morning. Welcome back. So, last class we did insertion of a node. Okay. So, before that, what is a node? A node is a part of a linked list wherein the data is stored in nodes. So, why do I need a node? Like, node has two parts. One is the information part, and the other one is the link part. So, in link part, what do I have? I have a pointer which points to the next node in the list. Like, see, in case of arrays, what happens is, like, if I say I need an array of 10 elements, then automatically, depending on the data type, that many bytes of memory would be allocated to an array. And array name is a constant pointer to the first element, location of the first element. So it points to the memory location of the first element of the array. And since it is contiguous memory location, that is, the elements are stored one next to another, or the memory allocated would be one next to another. You don't need to know the location of the or the memory location of the next element, because it is like continuous. You can traverse it. It would be one next to another. Why is it so? It happens because you need to declare its static allocation. It happens during the compile time only. So you declare, see, I would be having 10 elements, so that many bytes would be allocated during compile time before execution only. So that is why it would be total, that many bytes would be allocated. It is one block of memory wherein you can traverse it easily. Whereas in a linked list, it allows dynamic allocation. Dynamic allocation is, you don't have to specify the size of the list before only. Before, you may not specify. It happens during runtime. As and when you want to add elements, you can create a node. Here a node is a structure which will have an information part. You need to specify like what kind of data you're going to have in the information part, and the link would be pointing to the next node in the list, because every time you want an element, you using new operator, you dynamically allocate. That is, during runtime you create a node. That is why that it will not know, that entire block of memory would not be allocated. As and when you want to enter an element, you create a node, so it would be scattered throughout the memory space. Like, you don't have nodes located one next to another. They won't be continuous in memory. It would be scattered throughout. So you should know where the next node is, right? Otherwise, how will you form? They are like scattered. So you will have a link part which will contain a pointer which will point to the memory location of the next node, and the pointer would be of type node only, because you need to specify what the type of data type of the pointer. Also, when I create a pointer, I need to specify the data type of the pointer also, that what kind of location it is going to point. Like, if I say I have an integer pointer, it means that the pointer would be pointing to a location wherein it would be holding an integer value. Same way you would declare the pointer, that is, link would be a pointer which would point to a node. That is why it is called self-addressing pointer also, because it would be pointing to the same type of structure. And link would have a pointer. Link is a pointer basically, because in the structure I would have declared link as a pointer of type node which would point to the next node in the list. I can see here link is pointing to the next node in the list. So from here I cannot traverse back to the previous one. I don't have a pointer. I don't know the location of the previous node. In a single linked list, the node will have only the information about the next immediate node. I will not even know the different nodes. Like, I won't have the location of the different other nodes in the list, only the node which is immediately next to that. That is what is a single linked list. And in that you can traverse in only one direction from the first to the last node. Reverse is not possible, and unless it's a circular linked list, you cannot even go back to the first node. In a circular linked list, the last node is connected to head, which is pointing to the first node. Here also you can traverse in one direction, but after one complete traversal you can go back to the node. Whereas in a single linked list without circular, it happens like you start from the first node and the traversal ends in the last node. How do I identify the first node? Head is a pointer which points to the first node, and the link part of the last node is null. Once you encounter the link part where the link part is null, it means that you would have come to the end of the linked list. Now I already have an existing list and I have created a new node. Okay, I have allocated a new node and I want to insert the node inside the list. So there are three different options. One is to make it as the first node in the list. That is, this new node is there. Instead of this node, that is, which has the information point part 67, I want to make this node as the first node, and this becomes the at present first node becomes the second node in the list. That is, inserting a node as the first node in the list. The second one is attaching it or inserting it into the end of the list. That is, after the last node. Instead of this one making it point to null, I will make it point to the new node, so it gets attached in the end of the list. So these two we have already done, that is inserting a node in the beginning, inserting a node in the end. But now we will be doing wherein I would be inserting a node in between at a given position. Like how many nodes are there here? And nodes start from 1, 2, 3, 4. Since it's not array, I don't follow the subscript thing from 0 to n minus 1 every time I create a node. That is the node. This is the first node, this is the second, third and fourth. So there are 4 nodes here. Now I have created this and I want this as the third node, that is in the position 3. So I want it here. That is the after this I want this node, that is the node having information part as 56. I want it to point to this new node, and this new node I want to point here. That is what, like for example, I want to make the new node as position 3. In the position 3 I want it so that the at present in the list, the element which is there in the position 3, sorry, the node which is there in the position 3 should move off to 4, and the fourth one will go to the fifth one, and it would be the last node. So null, I don't have to change anything. So that is why I have not made the link part also point to null, because that wouldn't be pointing to null since I'm inserting it in between. Getting it? So that is, we did an algorithm yesterday, but many said that they were not able to understand it properly. So insertion at a given position is anywhere in between. So the first thing is, the first challenge is that it should be a valid position, right? Because there are 4 nodes and I want to insert it in the 10th position. There is no 10th position over here. So it should be a valid position and I should be able to insert. So you need to check whether the end, that is you encounter the position before the end of the list is encountered. Before the end of the list, you should be able to get the position which the user decides to insert. So that is one thing which you need to check. So first, what I have done, in each algorithm I need to first create the node and I need to insert the information part of that in the node. So I have created a new node. New node is nothing but a pointer which points to a node, right? And then temporarily it would be like, see, I will make it point to a node, then once I attach it I don't need new node, then I will use the same pointer point to some other memory location. That is the this thing, like pointers can be made to point at different locations throughout the program, right? Every time I create a new node, before attaching it to that, I will make this pointer only. I'll be reusing this pointer, point to that, or I can say I won't be reusing it also. In the function, every time when you call the function, I will declare it. So it's an automatic one. Once you go out of the function, it gets destroyed, and again when I call it, it creates again, because the first statement is declaring a new node of the type node. In the create function, I would be doing it. After that, once this new node, I have created a new node, I have put the information part in that. I have left the link part not equal to null. I have not made it to null because I am not making it as the last node in the list. I have to insert it somewhere in between. That is done. So according to the algorithm, like address of the new node, I have made it as new of node. After that, what I'm doing, copy the information part, that also I have done. Element 100 I had inserted. If you see, I have inserted 100, new node is pointing here, and then what did I do? What I need to do, I need to initialize the head to current pointer. Like I need to initialize current pointer to head. Okay, why I need to do it? Because I need to traverse the list from the beginning to the given position. So head is a pointer which points the to the first node in the list. Fine. So head is not a keyword. You can have it as, you can name it as first pointer, or you can make it as start. Whatever you have, should have a pointer basically which identifies which is the first node in the list, and it should always be pointing to the first node. Don't use it for traversal, because you will not be able to make out. If you keep on traversing, you will not be able to make out which is the first node. So you should have a pointer which would point to the first node, and if there are no nodes in the list, it will have the value null. Then current pointer, again this is like, you can name it as p or current pointer, whatever. It's just a user defined name given which is used for traversal. That is, from starting to end of list, wherever I want to go, I will start from the beginning and I go on traversing. Based on a condition, I will take that pointer to that location. So I need to, what is the, suppose if I want to make it as a third node, like the new node as the third node, ideally what I should do, I should make this second node point to this node, and this node's link point here, right? That is the ideal thing. Like this link should point to this one, the new node, and then the new node should point to the next node in the list. That is what I should do. Like 56, the node with the information part 56, the link part of it should point to the new node with the information part 100, and the new node's link should point to the node with the information part 89. This is how it should work. That is what in the location 3. So automatically, once that this node, link, the second node pointing to the new node, so new node becomes the third node in the position 3 I want to insert. And then this link part should point here, because there should be no cut in the chain, because the linked list should have a logical connection or logical relation. I should be between the nodes, like it should work similar to array wherein I can traverse the node, but then they are not physically stored next to one another, but then there should be a logical link between, there should be a link between nodes. So the at present third node would become the fourth, and the fourth would become fifth, and that would be pointing to null, because that is the last node in the list. So this is the thing what I need to do. If the position is 3, this is, I'm talking about position 3, initialize head, current pointer is equal to head, right? So current pointer, when I say is equal to head, where is the current pointer? At present current pointer is not pointing anywhere. When I say current pointer is equal to head, it should point to the first node, right? So current pointer is pointing to head. Now current pointer is equal to head. So current pointer is pointing to the first node. After that, what, move to the required position, because I need to move the current pointer to the required position. Head, I'm not moving anywhere. Head will always point to the first node only. For I, why I is equal to 1? Because for loop, for traverse I need to have a loop variable, that is I will be from 1, because linked list I don't have from 0 to this thing. I don't have the subscript value here, so it is not from 0 to this thing. It will be from 1 to n. There are n nodes, so 1 to n nodes it will traverse. From I is equal to 1 to position minus 1, that is 1 and 2. Here suppose I want to insert in the position 3. I am taking this example wherein I want to insert a node at the position 3. So I value will change from 1 and 2, because once it becomes 3, 3 is not equal to 3, it goes out of the loop. And I have two conditions here. Both the conditions should be true in order for the for loop to execute. Current pointer is not equal to null. Why is that so? Because suppose if I say position is equal to 10, it will go from 1 to 9. But there are only 4 nodes in my list, so it would have gone out of range. When there are no nodes, where will you traverse? So there should be nodes in the list. That is, you should not go out of the linked list. There should be nodes in the list, and then position minus 1. Both the conditions should be true. Then only the for loop will execute. That is, the position is not out of range, and then you have to traverse till one node before the position. Like if I want to insert the new node in position 3, then you need to stop at the node 2. Getting it? So you are going to traverse till the node, one node before the position where you want to insert, and then it is not the end of the list. So both the conditions should be true in order to execute the for loop. For I is equal to 1 to position minus 1 and current pointer is not equal to null, you have to do the following. Move the current pointer to the next node. Current pointer is equal to link of current pointer. So I is 1 and I'm pointing to the first node, that is true, and the link current pointer, that is link of current pointer, is not null, because the link of the first node is not pointing to null. So both the conditions are true. It will go inside the for loop, move the current pointer to the next node. Current pointer is equal to link of current pointer. So at present current pointer is pointing here, and then current pointer is equal to link of current pointer. Where is the link of current pointer pointing to? It is pointing to this node, right? It is pointing to this node. So current pointer is equal to link of current pointer. So for current pointer, instead of pointing to the first node, will point to the next node. So it will point here, right? So after that, what happens, we will see. So current pointer here, then it will go back, it will increment the value of I would have put that I would from 1 to position means it goes in the upper one. I will be incremented by 1, so it will be 2. Then current pointer, it will go back and check. So 1 to position minus 1, so I is 2. It will go back. Will it increment? Will it go and check? No, because I am already in that position. So it will go out of the loop. It will go out of the loop because it should be 1 to position, like I should be less than position minus 1. Okay. If it becomes equal to position minus 1, it won't. Once it becomes equal to position minus 1, it won't. It will go out of the loop. So it will be 1. The first time it was 1. So it is, now at present it is in position 2. So your position minus 1 is to, once it becomes equal to that, it goes out of the loop. And then what is there in the loop? Outside the loop, I am having, like, if current pointer is equal to null. Definitely it is not null, so it is not position out of range. I will come here and I will check. What is it showing? Link of new node is equal to link of current pointer. So I have to go back. Link of new node is equal to link of current pointer. Where is the link of current pointer pointing to? The link of current pointer pointing is here. You can see where the information to this node it is pointing. The link of current pointer is pointing to that node. So link of new node, this is the link of new node, is equal to the link of the current pointer. This is the link of current pointer. So I need to So link of new node is equal to link of current pointer. Yes, I am doing it. Link of new node is equal to the link of current pointer. New node is pointing over there. After that, what I need to do? The next is link of current pointer is equal to new node. Say here, link of new node is equal to link of current pointer. I did. Link of current pointer is equal to new node. So the link of current pointer is here. It should be equal to new node. So I need to take this out and it should point to the new node. So link of current pointer is pointing to the new node. Correct? So you can see how it got attached. That is, this 56 link part is pointing to the new node and the new node is pointing to the other node. This is how I inserted an element at a given location. Hopefully you've understood that. See, until it is less than position minus 1. Once it becomes position minus 1, I'll go out of the loop. So this was how you insert an element at a given location. We'll write the code module, that is function to insert a node at a given location. Please write it down. Function to insert a node at a given, I can say, position. So void, what is the function? It is not going to return any value. Please don't make a v as capital. V should be in lowercase only. Void ins, let me name it as ins pos, that is insert position. And what are the two elements I am going to pass? I am going to pass int element, which is for the information part. I would be passing it from the calling function. When during the function call, I am going to pass this as an argument to this int early and int POS. Position is again the user entered position, which position the user wants to the other two, like in the beginning and in the end, I don't have to specify the position because I already know the position over there. Here I need to take the position. Whenever you are inserting anywhere in between, you need to take the position from the user. The user need to specify where exactly he wants to insert the new node. That is why I am taking in the position as an argument as well as the element, and then I am passing it to the function during the function call. So insert position will have two arguments or parameters. One is the element which will be stored in the information part, and then the position in which the node would be inserted in the linked list. Getting it? So now the first thing is I need to, what I have to do, I need to first create, I need to declare a pointer of type node, right? Because I need to have a new node where then only I can dynamically allocate, and also I will declare a pointer current pointer. Or like if all these together you write in a program, you make it as a class, this thing, not the new node, but the current pointer and head you declare during that time only, so that it is easy. Every function you need not redeclare it, but new node, let it be there in this function only. Node, that is the data type, star new node, comma, star current pointer. Fine. These two are the pointers which point to node. After that, I will also have an integer variable I for, let me have an integer variable I. I can either have it in the function for loop header also I can have, or let me have it as here only. I will declare it. Let it be lowercase I. It's not uppercase because it's a int I. After that, I will say now you have to dynamically allocate memory using new. So new node is equal to, this is the keyword that is for allocating, this is the operator for allocating the memory dynamically, and you need to pass what, the data type, like what type of data, what type data type as an argument to it. Here I am passing the structure node. So that many bytes, like how many bytes you require to store one element of the structure, that many bytes would be allocated, and then new node pointer would be pointing to that memory location. After that, what will I do? I need to store in the information part of the node. This I would have declared in the structure. Whatever name you give the same name here also, is equal to, what am I passing here in the function header? ELE. So it will be equal to ELE. I am using arrow because it's a pointer. Otherwise, you will use a dot. If I have to use dot here, then star bracket dot. But don't complicate it, directly use an arrow. Next, what I have to do? I'm not making link part point to null because I'm inserting anywhere in between, in middle. So definitely the link part of the new node will not be pointing to null. It would be pointing to the next node in the list. Only when you're creating a linked list wherein each node is appended to one another, that one you will have the link part as null because that would be the last node, or you're inserting in an already existing list as a last node in the end, then you will make it as null. Otherwise you don't make it as null. If it's beginning, you will just make it as pointing to head, which would be first node, and head point to the new node. And here I am not doing it as null. as I traverse, I will stop it before the position -1, and then I will make it point to the next node. So the for loop condition is it will exit when it I becomes equal to position -1. So I should be less than position -1. Getting it? So for traversal, first before the loop, make this one current pointer point to head, because current pointer is a pointer used for traversing. I am using it for traversing the list, so I should start from the beginning of the list. So current pointer is equal to, how can I see? Whenever you are assigning a pointer to a pointer, you don't need an ampersand if it's a normal variable. Suppose if I want to make current pointer point to I should put ampersand I, because I would have a value. I cannot give a value to a pointer. I can have to make it point to a memory location only. But since both of them are pointers, I can directly make one pointer to point equal to another, wherein they both the pointers would be pointing to the same memory location, provided both are of the same type. See, head is also of the type node and current pointer is also of the type node, so both would be pointing to the same location. Now I can assign one to another. After that, what will I do? I will have to traverse the list. So it will be for I is equal to 1, I less than position -1, and current pointer is not equal to null. So I is equal to 1. Here if I have not declared I before, you can say I is equal to, this one has to be lowercase I, because I have declared uppercase, and if I am using lowercase, it will give me variable undefined error. So make sure the case are same. For I is equal to 1, then I less than position -1. Where do I get the value of position? Position, I am passing it as an argument, wherein main I would have taken, asked the user to enter the position, and I would have taken it as an argument, and I would have passed it to the function during the function call. So that is why I am not taking position here in this function, nor I am taking the information part, because I am passing the information part also as a argument from the calling function to the called function during the function call. So I less than 1, I should be less than position -1. Once it becomes equal to position -1, there also in the example I showed you, like if I want to insert in position 3, and once current pointer is pointing to position 2, it went out of the loop because it became equal to. So I should be less than position -1. When I am writing an algorithm, I will not be very clear, like you may get confused like whether it should be position -1 equal to or less than. But when you are writing a program, you have to be very particular, because if I say equal to, then it will not become the third node. It won't serve the purpose there. So I is less than position -1, and position should not be out of range also, right? And then I will use logical and. What does it do? The logical and, both the conditions should evaluate to true, then only it is true. Otherwise, if one of this becomes false, then it is 0. That is, the truth table would be 1 and 1, that is true and true is true. Otherwise 0 0 is also 0, 1 0, and 0 1 also gives you a 0. So both the conditions should be true in order to the loop condition to be true. So current pointer not equal to null. The current pointer should not be null. Both the conditions should be true. Then only the loop will execute, and then I plus plus. This is my for, and I am going to traverse the for loop. So how will I do? Current pointer is equal to current pointer link. So I'm traversing it. I'm closing my for here. That's what I'm going to do. After closure, what I'm going to check whether the current pointer is out of range or not. Otherwise, if it is not out of range, I'm going to attach it to the given location. If, because see, it will exit the loop once the correct pointer, it will not give the message to the user like why it is not proper or correct. So if r is equal to, if current pointer, you have to use double equal to here because I'm checking whether it's true or false. If current pointer is equal to null, C out and del position out of range. Then I will exit. This is the end of if. Else, if is not true, or I need not write else also, because simple if this is not true, it will not go inside. It will not go inside. If it will not go inside, if it will go, since in if I have an exit condition, it will just go out of the application itself, so you don't have to worry. Like after that, I have new node. I'm making the link part of the new node is equal to current pointer link. I showed you that also. And current pointer link is equal to new node. Yeah, we established this when I showed you with the diagram how it works. And then this is the end of my function. This is how you insert a node at a given location. Hopefully you have understood that. Please go through this. So with this we have finished all the three, that is insertion in the beginning, end, at a given position, and then creation of a linked list is also done. Now we are left with deletion of a node in the beginning, in the end, and at a given location. So after that we'll be just doing trees and graphs, which would complete your data structures chapter. And while doing the chapter itself, I have shown you all the lab programs and I've explicitly specified also that these are the lab programs for you. So we finished with inserting a node. We will start with now deleting a node. So what do you mean by deleting a node? Say for example, I have created, like if you have an array for, if I have 10 elements and I have declared an array of 100 elements, so I cannot release the memory which of 90 elements so that it can be reusable. It cannot be done that way, because once you allocate memory it gets locked. So it will not be used. You cannot make use of it again by any other programming element. Cannot make use of the memory whether you're using it or not. I may have declared for 100 elements, but I may be having only 10 elements, so I may not be using the other 90, but then I will not be using it. I cannot make use of it for anything else also. It becomes locked and it's a waste of memory because the allocation happens during compile time for an array. Whereas for a list, what happens is, as and when I want to add an element, I dynamically allocate memory and then I go on adding it to the list. The same way, if I want to delete an element or a node, if I delete a node, what happens is I can release that memory and it can be reused by any other element during runtime only. That is, allocation and deallocation is dynamic. That is, during runtime I can deallocate the memory which is used by the node when I delete a node. How do I do that? Using delete operator, that is deleting an item from the linked list. So that is how it is beneficial, that as and when my size of the list grows higher, I allocate memory. As and when it shrinks, I can deallocate that memory also so that it can be reused. That is what I said when I was teaching you queues. That is, an ideal queue is always dynamic. That is, the size of the queue will not remain the same throughout. Like many elements can go out of the queue and the size of the queue can shrink dynamically or it can expand dynamically. So an ideal one where the size of the queue is increasing or decreasing, then it is always better to have a linked list implementation of it rather than the array based implementation. Here also, deleting a node is deallocating memory. I can reuse the memory which is deallocated during runtime. So deleting an item from the list. Deletion, again, the first node, I can delete the element that is in the first node, the deletion of the last node, or the deletion of the node at a given position. These are the things which I can do. That is, I can delete the first node and of the linked list. That is, already a linked list should be there for this. Otherwise, you are trying to delete a node from an empty list, then it will give you a underflow condition. There is no overflow because I am not specifying the size of a list over there. Overflow comes when you are trying to insert more than the size, but then I don't have a size I don't have to declare a size. As and when I need to have a new element, I go on creating a node. Unless and until there is no memory space available, it will give you an error. As long as memory is available for allocation, you won't get an error because the size of the list is not fixed. Uh, but then if you want to delete an element, then there should be at least one node in the list. If it's an empty list, like there are no nodes in the list, then you cannot delete anything. So you need to check for the underflow condition when you are deleting a node in the list. So deletion, when I say deletion, see, computers do not have infinite memory storage, and then so you should, at any point of time, you cannot have infinite nodes. Yes, I don't have to specify the nodes, and dynamically memory would be allocated as long as the space is available. So if you go on continuously allocating memory and not deallocating, then it is of no use, right? So you need to delete the unused memory spaces, or whichever is not there in use, you need to free the memory so that it can be reused. So you can create nodes as long as memory is available. It is finite. Definitely computer memory is not infinite, so you cannot have infinite nodes. And then deletion of a node is nothing but you delete a node so that you can free that memory space and it can be reused by any other element. So deleting an item can be the first, the last, or at a given position. we can easily denote the first node, delete the first node of the linked list by changing the start. Here it is start, wherein you can refer it as head. Head and start are same to point to the second node of the list. If there is only one node in the list, make it as null. What do you mean by that? See, I have a linked list and this was supposed to be the first node, that is the information part, the node having the information part. 20 would be the first node in the list. Then you have 30 totally. How many nodes are there? 4 nodes are there, and the last node, that is the node with the information part, 40 is pointing to null. So it is the last node. So what you have to do is, it is very easy if you are going to free the first node, because you have to just make head. Here start and head, that is what I have been telling you. It can be first pointer, start, head. Only thing is, you should have a pointer which specifies which is the first node in your list. So I say start would be pointing to the first node. In this, start and head are same. So what you have to do, you have to just make it point to the second node. So automatically it becomes the first node and you can free the node which you have deleted. And then you need to check. Suppose if it is the only node in the list, so once you delete it, it becomes empty. Then you need to make it as null, because next time when you try to delete, it should give you underflow condition. And underflow only if head is null. When head is null or start is null, there are no nodes in the list. So it will give you, if you try to delete a node from the list wherein the head or the start is null, it will give you an underflow error, because you are trying to delete from a list where there are no elements in it. So you have to first, if you want to delete a node in the beginning, just make head point to the second node. So automatically this goes out and then you can delete it. Then you need to check whether that was the only node. If it was the only node in the list, then it has to, you have to make start as null. How will you know that is the only node in the list? If the node to which head is pointing to, the link part of that node is pointing to null, that is the first and the last node, because the link part of the last node is always points to null. So when the node to which head is pointing to means it is the first node, and if the link part of it is not pointing to some other node, it is pointing to null, it means that it is the last node in the list, or I can say that is the only node in the list. If the link part of that node is pointing to null, it means that it is the only node. So just make head point to null, automatically that gets deleted, and then it shows it's an empty one. That is, we can easily delete the first node of the linked list by changing the start or the head to point to the second node of the linked list. If there is only one node in the linked list, the start will be stored with null, will be assigned with null. Getting it what I'm doing? I will just go through this, then we will write the algorithm also for that. I will write it and explain rather than going through the PPT. To delete the last node, we should first find the location of the last node. Yes, because I should know which is the last node. First is very easy. I don't need any traversal. To whichever the head or the start is pointing to is the first node. But then I'm not sure how many nodes are there in mine, and I need to traverse the linked list from the starting to the last, and then only I can do it. To delete the last node, we need to first find the location of the second last node, because I need to make the second last node. How many nodes are there? Four nodes, and P1 is the second last node and P2 is the last node. First you have to find whichever is the second last node by assigning null to the link field of the second last node. The last node of the linked list can be deleted. So this one also I will show you how exactly we can do that, right? So how do I traverse the linked list? How do I find the second last node, and then how do I get that? So is it possible with only one pointer? I cannot do it with one pointer. I need 2 pointers here. One is for the last node, because to begin with I will not know which is the last node. Only when I go to the last node, that is the link part of it shows that it is null, then only I will know it is the last node. So how do I get the second last node? You need 2 pointers here. One is the current point, that is P1 and P2 are the 2 pointers, or I can say current pointer and the previous pointer. Those are the 2 pointers which will tell me which is the last node and which is the second last node. So here what I have to do is P1 and P2 are the 2 pointers which will be pointing to the last and the second last node. Just make the second last node's link part point to null. So automatically that becomes the last node, right? Because when it points to null, it will have no clue about the other node, because it automatically goes out from the linked list. It is detached from that, because that there is no, see, first node points to the second, to the third, and then the link part of the last node points to null. So you need to traverse the list from one to the last and the second last, because I don't know how many nodes are there. So you cannot say that these many times you need to traverse, that is, you need to jump the current pointer, you will reach the last node. So reach the last node and the second last node, you have 2 pointers P1 and P2. Make the link part of the second last node point to null, so automatically that gets deleted. I want you to note it down, this one also and the other one. Please make a note of this. And then the note of this also. I will write the algorithm part of it. We'll be writing the algorithm for deleting a node at the beginning, deleting a node at the end, and at the given location. All the three are there in your syllabus. So we'll be starting with deleting a node at the first. Fine, I'll write it and I'll explain it to you, so it will be easy for you. So we'll be doing this in the next class, as we'll need little more time for this. So we'll do the deletion of the first node and the last node in the next class, and then after that I'll put everything in one program, the insertion, the deletion, and I'll show you the execution, how exactly it works. Okay, till then, no homework for today. Take care, stay safe. See you tomorrow. Bye bye.